There's this quiet but massive revolution happening right now inside the world's biggest tech companies. For decades, they were happy to rely on other companies for the brains of their operations, but now they're building their own. So what's going on? Why are giants like Google and Microsoft suddenly jumping into the chip-making game? Let's break it all down.
Okay, so for the longest time, the tech world was all about what we could call the general-purpose era. You just bought standard, one-size-fits-all chips off the shelf. But that's over. We are now deep in the custom silicon era. And what that means is companies are designing their own chips, tailor-made for really specific things like AI and cloud computing. And it's all in the name of one thing: maximum efficiency.
So yeah, why are they doing this? I mean, this is a multi-billion-dollar question, right? And the answer is actually driving this huge strategic shift across the entire tech industry. So let's really get into the why behind it.
All right, to really get why this is such a big deal, we got to look at how things used to work. For years, the model was super simple. If you were a company like Google or Microsoft, you just bought your processors, the CPUs and GPUs that are the brains and the graphics powerhouses from the big dogs like Intel and NVIDIA. Easy.
The best way to think about it is like buying an off-the-rack suit. You know the kind. It fits okay, it gets the job done, but it is definitely not tailored to you. Well, general-purpose chips are exactly the same. They're designed for everybody, which means they're not perfect for anybody. They often have features you don't need, or they're just not super efficient for the really specific, really demanding jobs that modern tech companies have.
So what happened? What broke this one-size-fits-all model? Well, it was a perfect storm of two massive trends: the absolute explosion of artificial intelligence and the unbelievable scale of cloud computing. These new workloads are just incredibly intensive, and they demanded a level of performance and efficiency that those off-the-rack chips just couldn't deliver anymore.
And this new reality? It basically created four key drivers that started pushing these companies toward making their own custom silicon. So let's unpack each one by one.
Driver number one. It's the most straightforward reason of all: pure, raw speed. We're talking about performance optimization. By designing their own chips, these tech giants can unlock a level of performance that generic hardware just can't even dream of touching.
Think about it this way. Instead of having one chip that's trying to do everything, imagine a chip that is designed only to process YouTube videos, or one that's perfectly tuned just for a chatbot's AI. By literally stripping out the circuitry they don't need and supercharging the parts they do, these companies are creating these hyper-specialized processors.
And the results, they are absolutely staggering. Get this: Google's own custom-built video processing unit, they call it a VCU, it processes YouTube videos 20 times faster than a general-purpose chip ever could. 20! That is a game-changing leap in performance.
Okay, on to driver number two: cost reduction and efficiency. This one is all about the bottom line. Because while designing a chip from scratch is crazy expensive up front, the long-term savings are just enormous.
A massive chunk of a data center's cost is just the electricity bill, literally keeping the lights on and the servers cool. Well, these custom chips are designed to be 2 to 3 times more power efficient. Now, when you spread that across thousands upon thousands of servers, that adds up to hundreds of millions of dollars saved on power alone. It's huge.
And then, there's something that people in the industry have started calling the NVIDIA tax. This is where it gets really interesting. See, the AI boom created this insane demand for powerful GPUs, and for a long time, NVIDIA was pretty much the only game in town, and that let them charge premium prices with huge profit margins. By building their own chips, these tech giants can just sidestep that tax entirely, saving billions in hardware costs over the long run.
All right, driver number 3 is all about strategy. It's about taking back control of their supply chain, and ultimately, control of their own destiny.
Let's be real, the AI boom created a massive GPU shortage. And if you're a company that relies completely on an external supplier, you are at their mercy. Your growth can literally be stopped in its tracks. So having your own internal supply gives you stability for sure, but it also gives you incredible leverage. Imagine walking into a negotiation and being able to say, well, we have our own alternative. Suddenly, you're in a much stronger position to get a better deal from those outside vendors.
And that brings us to the fourth and final driver. And this one is maybe the most ambitious of them all: complete vertical integration.
What we're seeing here is basically the Apple playbook, but for the cloud. We all know Apple gets incredible performance out of its iPhones because it designs both the hardware, the A-series chips, and the software, iOS. Well, Google and Microsoft are doing the exact same thing now.
They're creating this seamless stack that goes all the way from their custom silicon at the bottom, up through their cloud servers, all the way to their AI software at the top. And having that total control gives them a performance edge that competitors who are still using off-the-shelf parts just can't possibly match.
Okay, so now we know why they're doing all this, but what are they actually building? Let's take a quick look at the actual custom chips Google and Microsoft have come up with.
So Google's actually been at this game for a while. They started with their first TPU way back in 2016. Their strategy is pretty broad. It covers everything from AI to their mobile phones. Microsoft, on the other hand, is a bit newer to the party. They really started ramping things up in 2023, and they have this laser focus on one thing: making their Azure cloud platform more competitive.
So here's a quick little side-by-side breakdown. For AI acceleration, Google has its famous TPU, the Tensor Processing Unit. Microsoft's answer to that is a chip called Azure Maia. Now for the general data center stuff, the CPU, they've both switched to these super energy-efficient ARM-based designs, kind of like the same tech that powers your smartphone. Google calls their chip Axion, and Microsoft's is Azure Cobalt. But look at the primary goals here. They're a little different. Google is trying to optimize its own huge suite of services like Search and YouTube, while Microsoft is all in on beefing up its Azure cloud platform.
So when you look at all this, what's the true end game? This is really important because we need to clear up a very common misconception about what's happening.
Here's the big misconception. A lot of people think Google and Microsoft want to be the next Intel or NVIDIA, that they want to sell chips to everybody. But the reality is much more focused. They are not trying to sell these chips to you or me. They are building them for one customer, and one customer only, themselves.
So this is the ultimate goal. All of this incredible in-house silicon is designed to do one thing: make their own AI services and their own cloud infrastructure faster, cheaper, and way more efficient. The chips aren't the product. The chips are the weapon in a much larger war for who will dominate AI and the cloud. And you got to get this. By controlling the absolute foundational layer of computing, these companies are fundamentally changing the power structure of the entire tech industry.
It really is kind of like a modern tech fairy tale, isn't it? I love how the source material put it, with this charming little summary. Once upon a time, the great wizards Google and Microsoft crafted their own magic stones to power their cloud kingdoms, making them faster, smarter, and more wondrous than ever before.
So the key takeaway here is pretty clear. This isn't just about building better processors. This is about building self-sufficient, highly optimized digital empires. And all of this leaves us with one final, really critical question to think about. Who's going to be the next giant to forge their own path in this new custom silicon era?